Good morning, everybody. We have made this presentation to give the update of the Sprint 6. In this sprint, we got 2 weeks time, so we had 4 Scrum meetings. As usual, the sprint started with the sprint planning documentation. This is our sprint planning documentation listing the tasks we plan to do throughout the whole sprint. Here, we have assigned the tasks for each and every member with an estimation of hours they would need to complete the task. After that, we made the retrospective meeting and found out the lessons learned. Lessons learned from last sprint were as follows. Dividing tasks makes it easier and faster to complete them. Having all team members' viewpoint leaves a big impact on deciding the path to complete the sprint task. Meeting several times apart from Scrum meetings are really beneficial, even though it's not face-to-face, over the phone, or on Facebook chatting. Meeting minutes weren't created for every Scrum meeting throughout this sprint. It's important for every member to know a new technology, like Azure or ClickView, so that when one gets stuck, the other one of the team can help out. Here we have our updated Gantt chart. As we can see, we are within the time frame. We are not lagging at all. We have our PERT chart too over here. So we are actually within the time frame. The challenges we faced during the ClickView. First of all, we chose ODBC driver and had trouble understanding some terminologies like what it means by the data source. However, we didn't have any trouble connecting with SQL Server. We could easily connect it with SQL Server in a minute. But later on, we were successfully able to connect Oracle. As we learned from the tutorial to create the select statement, we selected the owner database and selected the tables we wanted to choose and clicked Add and then clicked OK. And to reload the script, we clicked Reload button and got tables desired on the main worksheet. Here we can see we selected OLEDB driver and Oracle provider OLEDB for Oracle connection and clicked on Next. Then for the data source, we added ORCL, and for username and password, I used the username for the database I used to connect to the Oracle and put the password for it. And for test connection, it was connected successfully. Then for the Oracle database owner, I had to select the database for the owner, that is OLFOAES for my database, and select the tables I wanted to be added in the worksheet. Then to get to the chart, after reloading, we get the tables as shown here. And to get to the chart, we had to click on the chart on the tools option up there on the top we can see, and then you use the quick chart feature for the data to be shown in the graphical view. And for second step, we used campaign number and campaign name as shown in this picture. Later, for the third step, we used sum of profit total. This is the query that we wanted to run and analyze the data with, and this is the data we are getting. It shows the sum of profit total for each campaign. On the right corner, we have campaign numbers, and at the bottom we have the sales, we have the name of the campaigns, and the vertical axis gives us the sum of profit total for each campaign. We are also successfully able to generate another graph. We have 14 campaigns. We selected the campaign number as the vertical axis and the sum of our products in 2003 as the horizontal axis, and we can get numerical demonstration for sum of each product sold in each campaign for 2003. This is another example of how we selected campaign number 7, which is sense of deal, and we selected the decision that how many campaigns perform poorly.
Next task done in this sprint was to implement the distributed fuzzy version of the local fuzzy database that we did in the last sprint. During our sprint planning, we asked individual team members for which option to choose, either to use local implementation or go for the cloud, and we all unanimously went for the Azure cloud. Having the platform, our next task was to design the distributed architecture. So this is our distributed data model. Here we have implemented three cloud infrastructures. Here we have used three different VMs in the cloud. One is for Oracle, one is for SQL Server, and one is for MySQL. Our local fuzzy will be in the local database where we have all fuzzy related tables and procedures. This is our data model for the fuzzy tables and procedures. In the sprint planning, we also identified how tables should be arranged based on the region and how tables will get fragmented for the distributed implementation. The final decision team came up having Oracle database to have region 1 and 2 related tables. MySQL database have region 5 and 6 related tables, and SQL Server database will have region 3, 4 and 7 related tables. Also, we identified the tables that should be horizontally fragmented, vertical fragmented, and hybrid fragmentation. This table depicts the columns that will be slitted for the vertical fragmentation and the tables also in which schema or in which database does those tables rely. Similarly, table promotion and quantity discount are vertically fragmented. The promotion table was split into two parts with columns. Product number started ended in region Oracle database and promotion and discount in the SQL Server database. Thus, vertical fragmentation was implemented. For quantity discount table, we use quantity discount number, minimum quantity, maximum quantity in SQL Server, and quantity discount number, discount price, product number in MySQL schema. Also, we created a hybrid fragmentation for the product table. The SQL Server holds all the columns but only half of the rows, and Oracle holds half of the columns and remaining rows, while MySQL holds half columns of the promotion data table as shown in the chart here. Thus, we designed our fragmentation structure before we move to the implementation. As we make decision to implement Azure in cloud, the next step was to create account in the cloud and install MySQL, SQL and Oracle servers. Here is one example that we have implemented SQL Server in the Azure cloud. One team member has implemented MySQL in the Azure cloud and the next team member has implemented Oracle in the Azure cloud. Thus, we set up our environment. To access all those servers to each member locally, we created the linked server in SSMS in the localhost. Here we can see the connection string for Oracle and SQL Server. For MySQL, we created a DNS and Microsoft ODBC driver for MySQL. This one is for connection to the Oracle, and this one is for connection to the SQL Server. We can see these linked servers being generated here. This is our SQL Server linked server connection string. Here we have a MySQL connection, and here we have our Oracle Azure cloud, all those different servers in the cloud. Here we can see the linked server objects. Each object has its own catalog, and each catalog has its own schema, and each schema has its own table. So these are the tables we are able to view. Those are in the Azure SQL Server database, which is in the cloud. So with this, we are now able to access our distributed database for Oracle, SQL Server and MySQL while being in the local a SQL Server database. To find the fuzzy decision, we need data from different servers. So we first created a staging table in local server from where we run the fuzzy. Then executed the open query to populate those tables. From the staging tables, we generated WeightNet tables, and we get WeightNet tables populated. We run the fuzzy procedure and trigger and functions and fuzzy related tables to get the fuzzy decision. So as we have our tables having vertical partition, horizontal partition, and hybrid partition, we use join operator to merge the vertical partition table. We use union all operator to join the horizontal partition table, and we used both union all and join to get the data in the staging table for hybrid partition tables. Here is one of the open query, which is combining the vertical partition table from different database into the local fuzzy. So we are going to run this query. This is the same query, execute. Thus we are able to get the result of the query using open query from Azure SQL Server, Oracle Cloud, and MySQL. This proves that we are able to fetch the data from the distributed environment in the local schema using open query. The fuzzy has been successfully implemented in the distributed environment, and here we have some use cases we ran, and this is the result we obtained after executing the fuzzy. This is the next query after execution of the fuzzy. With this, we completed our sprint6 tasks, and credit goes for all the team members' hard work. Thank you for watching this, and we will be back with the sprint7 videos again. Thanks.